this video, we'll see how to prove that root 3 is an irrational number. This was asked in 2019 for 3 marks. Series details have been provided for your reference. The approach is similar to how we proved the irrationality of root 2 in our previous video. So the question is, prove that root 3 is an irrational number. The method used here is called proof by contradiction. In proof by contradiction, we assume that the statement opposite to the statement to be proved as true. The statement to be proved here is that root 3 is an irrational number. So we assume the opposite, that is, root 3 is rational. Let's assume that root 3 is rational. All rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. When p and q are reduced to their simplest form without any common factors, it becomes a fraction of coprimes. So let's express root 3 as a fraction of coprimes where a and b are coprimes and b not equal to 0. Let's bring b to the left hand side. We get b root 3 equal to a. Now on squaring both sides, we get 3b square equal to a square. Squaring both sides. This becomes our equation 1. Here, 3 multiplied by a number is a square, which means 3 is a factor of a square. If 3 is a factor of a square, it implies that 3 is a factor of a. This is as per a theorem from this chapter. If a prime number divides a square, then it also divides a. And this becomes our statement 2. We arrived at the conclusion that 3 is a factor of a. Since 3 is a factor of a, there should be a number c such that a is equal to 3c. So let's substitute this value of a in equation 1, which is 3b square equal to a square. So substituting in equation 1, we get 3b square is equal to a square becomes 3c the whole square. So this becomes 3b square equal to 9c square. On cancellation, we get b square equal to 3c square. So 3 multiplied by a number is b square. Therefore, 3 is a factor of b square, and this also implies that 3 is a factor of b. Again, by the same theorem. If a prime number divides a square, then it also divides a. So this becomes our statement 3. In statement 2, we see that 3 is a factor of a. In statement 3, we have 3 is a factor of b. So from 2 and 3, we can conclude that 3 is a factor of both a and b, or that 3 is a common factor of a and b. Therefore, from 2 and 3, 3 is a common factor of a and b. But we assumed that a and b are coprimes. In that case, they should not have any common factors. So here we have arrived at a contradiction. This is a contradiction to a and b are coprimes. This is due to our incorrect assumption, which means our assumption is wrong and that root 3 cannot be expressed as a fraction of coprimes. Therefore, root 3 is an irrational number. So the method used here is called proof by contradiction. In proof by contradiction, we assume that the statement opposite to the statement to be proved as true. Here the statement to be proved is root 3 is an irrational number. So we assume that root 3 is rational. All rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. When reduced to simplest form, it becomes a fraction of coprimes. So we have expressed root 3 as a fraction of coprimes a and b, and then we brought b to the left hand side and squared both sides to get 3b square equal to a square. 3 into a number is a square, which means 3 is a factor of a square, which also implies that 3 is a factor of a. If 3 is a factor of a, there should be a number c such that a equal to 3c. Substituting this value of a in equation 1, 3b square equal to a square, we get 3b square equal to 3c the whole square. On simplification, we get b square is equal to 3c square. Therefore, 3 is a factor of b square, and this also implies that 3 is a factor of b. From 2 and 3, we can see that 3 is a factor of both a and b, or 3 is a common factor of a and b. But since we assumed that a and b are coprimes, this is a contradiction to our assumption, and this is due to our incorrect assumption. Therefore, root 3 cannot be expressed as a fraction of coprimes. Hence, root 3 is not a rational number, or root 3 is an irrational number. Hence, proved.